Most of the world population now lives in cities, where climate risks are amplified by urban characteristics and the high density of people, building activities, and heritage exposed to these risks, which are expected to worsen with climate change. It is therefore crucial to understand how cities are sensitive to extreme weather events, how these risks may change in the future, and how we can adapt to the current and future events. 56% of the world population, 4.5 billion in 2020, is concentrated in cities as of most industrial, commercial, and service activities. By 2050, around 68% of the world population, 6.4 billion people, will live in urban areas. City occupies less than 2% of the planet's surface, but consume around 78% of global energy. City produce around 75% of global greenhouse gas emissions, also known as GHG, with the transports and building sector accounting for most emissions. 70% of the world's cities are already facing climate change problems, and almost all are at risk. More than 90% of urban areas are on the coast, putting most of the planet's city at risk of flooding from rising sea level and coastal storms. Sea level rise increased the risk of coastal flooding for most cities on the coast. However, urban areas face other specific climate risks, which are expected to increase with climate change. For example, the material used in the construction of buildings, their density, the scarcity of green spaces and water bodies, pollution, and heat emission from building and transport are all factors that contribute to generate urban heat islands, a thermal contrast between temperatures in warmer urban areas and surrounding rural areas. This phenomenon aggravates the effect of heat waves, increasing thermal discomfort, with consequences in the increased mortality of the elderly and the sick. Also, the sealing of urban soil reduces the infiltration capacity of water, which can aggravate groundwater scarcity, but also accelerate the circulation of rainwater, causing flash floods or landslides. In addition to reducing GHG emissions, using less polluting transport, reducing consumptions, using renewable energy sources, etc., our urban lifestyle can adapt to climate change in order to reduce our vulnerability to climate risk. The best adaptation options in urban environments are the so-called nature-based solutions, which have many other benefits and involves, for example, the renaturalization of waterlines, the afforestation of public space to increase the area of shades, the creation of water spaces, uppaving to increase infiltration and reduce the speed of rainwater runoff, or the use of green roof in walls in buildings, which passively increase their thermal insulations. Other options contribute to adapting cities to water scarcity and include adapting buildings to make use of rainwater and wastewater, reducing water waste. Most of the world population is exposed to climate risks specific to urban areas, such as coastal flooding, heat waves, flash floods, and landslide, but also water scarcity, aggravated by increased human consumption. Climate change will mean an increase in these risks in almost all cities and require us to adapt to its effects in order to minimize the consequences. Adaptation in urban environments must favor the most advantageous solutions, which restore the territory's natural balance. Does the city where you live suffer recurrently from extreme weather events, floods, heat waves, storm, drought? Try to understand if over the years these events have increased in frequency or intensity, which area of your city are most affected, and which population groups are most vulnerable.